Hey everyone, so I'm going to tell you about seismic or seismic waves. I'm not really sure what is the best way to call them, okay? So I'm going to say seismic waves, for example, or seismic. Sometimes I will change. Anyway, so these waves are produced in an earthquake. They spread out from the epicenter. They can be P, S, or L waves. There is also another type, but you don't need to know that type if you're doing at GCSE level. And they travel through the earth, of course, and they are used to study the structure of the earth. So, before I tell you a little bit more about waves, let's just know this, some keywords. So they are these seismometers, and they are detectors that record earthquakes. And this is how they look like. So there is a frame, there is a weight attached to a spring, and whenever the earth is moving, this weight is going to move around. And it doesn't get out of the place because of the spring, but it can move up and down, sideways, any of these things. And it's going to be recording, these movements will be recorded because you have a pen attached to a rotating drum. And as the rotating drum moves, it will show the movement that the weight is doing. So it will tell you if an earthquake is going on and how strong it is. This rotating drum has paper, so you never overwrite on top of other recordings. You have the focus. The focus is the point where the earthquake originates. So we have some faults in the earth structure, and sometimes there are some forces that are going to cause these faults to kind of move past each other or slide through. So there's going to be a lot of force in that part. So that's the focus, the point where the earthquake is going to originate. And the epicenter is the nearest point to the surface of the focus. So it's immediately above the focus, okay? And that's where, you know, on the Earth's crust, where the earthquake kind of was, okay? So there are different types of seismic waves or seismic waves. So in here, this first one, I'm just showing the material without waves, so undisturbed. Then you can have the pre-waves. These are the first waves to arrive. And as the direction of the wave moves from left to right, the wave is going to push-pull things. So you have areas of compression and areas of expansion. So it is a longitudinal wave, okay? Then the second waves to arrive are the secondary waves. So they move things up and down as they move from left to right. So they are transverse waves. Then you have the Rayleigh and the long waves. I don't know why it says love waves in here. At least we teach it as long waves. And they are a little bit different. Let me get to those, okay? Now, I also added here these two pictures that I found on the internet. They are not mine, and these are good ways for you to memorize about P and S waves. P stands for primary. They are fast, so that would read as fast, push-pull, longitudinal, and compressive, while the S waves are secondary. They are slow, they are transverse, they are solely in solids and shear, so they only move in solids. You will know more about that in detail just in a few minutes, okay? So, waves. What do we need to know about these three types of waves? I have the P waves, which are primary. The first ones to arrive, they are longitudinal waves. They last about 1 minute, and they push-pull the material, okay? Then I have the secondary waves. They are transverse. They arrive second on the detector. They are slower than P waves, of course, and they shake the material side to side. And finally, I have the L waves, which are the long waves. They are the last to arrive, slower than P and S waves. They only happen in the Earth's crust, and they cause movements up and down as well as backwards and forwards, okay? So they are quite violent, and they do a little bit of everything, okay? Now, the energy that is released during an earthquake, this energy travels in the form of waves around the earth, and there are different ways, they are different in the way that they travel. So, scientists, especially using P and S waves, could figure out the structure of the earth, okay? Because sometimes some waves would arrive, other times they wouldn't, and all these things. The long waves pass through the crust all around the earth, so they didn't help as much as P and S waves. So the P waves, which arrive first longitudinal and they are primary, they are detected near the earthquake center, just like the S waves, which are the secondary. They are transverse, they arrive second. However, only the P waves can be detected on the other side of the earth. And this is because P waves can travel through solids and liquids, and the S waves can only travel through solids. So this means that the liquid part of the core blocks the passage of S waves. So as you have an earthquake, you have detectors all over the world, and they are, studying these waves. So when they would not see S waves, by knowing the degree where the S waves would not appear, they could get an idea of the diameter of the part inside the earth where is liquid, and therefore S waves could not pass through, okay? So this is more or less how it works. I have here the epicenter, and I have the P and the S waves. As you can see, the S waves only arrive at certain points, okay? So that means that here is liquid, that's why I have this shadow zone where I didn't get the S waves. So I can, by knowing the degrees where the S waves are not showing up, I can know what is the diameter of this part, and then I know, okay, this part needs to be liquid. In terms of the P waves, again, they are generated, but as you can see, they refract, they change direction and speed as they arrive to a different boundary. Now, P waves could still pass through, but because they were changing direction, how much they change direction and speed, I could figure out not only the diameter, because they are in different places where they are going to change more or less direction, but I could figure out kind of the density, the type of material that probably I would have, and the diameter where I would have that material inside the structure of the Earth. So the earthquake waves, the PS and the S waves, are helping us, or did help the scientists to figure out the Earth's structure, okay? This is because P and S waves, they've refracted boundaries, and because there is an existence of a shadow zone where the P and the S waves are not detected, shows that there is a liquid outer core under the mantle, okay? So this is all for today in terms of seismic waves. I hope it made sense. Up to my next video, be happy and healthy. Bye!